Zombie, Batteries and Motors, 2018-2019 new ones. Can they eat the competition and march their way to the top? Well, the only way to find out is to test them, see how good they are. Now, a couple of things to say before I start. Batteries have been very good for a couple of years now. The top of the range competition packs from all sorts of people. The factories have really got on top of how to make high performance ones that don't swell up anymore. They're very low resistance, very high voltage, really perform well. So any differences in new batteries that come out are normally very small. That's why I have to measure them as accurately as I can, and I'm redoing those battery tests now with my own discharger here, high current discharger, about 40 amps continuous, and I now measure the voltage directly at the terminals with this little electronics unit, which I've tested, and it's calibrated spot on. I really like that. And it gives an accurate voltage at the terminals. I also measure the capacity and measure the voltage at certain milliamp settings, say at 200, 500, 1000 milliamps, up to say 2000 and 3000 milliamps, which represents the draw on a Blinky car 17.5 or 13.5, and it's Blinky class that we're really worried about on the performance of batteries, because in modified and boosted classes the battery performance is not the most important factor. In fact, sometimes especially with modified, the battery performance has to be turned down a bit by not fully charging them, because there's just too much power available. So Blinky class 17.5 especially, the voltage of the battery really makes a difference. And if you ever race, which I do, you can tell the difference between one really good pack and another really good pack which is slightly better, especially towards the end of the race. You just notice the lap times are just a little bit quicker. And so when I test them, I write it all down on charts here. I measure the voltages against the milliamps, and I write it all down, and if necessary I retest if I don't think it's come out quite right. I do cycle the batteries up once before I test, and then I test them all at ambient temperature, so everything's exactly the same. I charge them up at 20 amps, and then they come straight off and go on the tester, so there's no waiting around while the voltage drops or anything like that. So I try and do everything the same. So that's why I'm going to retest on the same piece of equipment some class leading batteries, in my opinion, which will be the IPs, just so that I can make sure that the comparison is spot on. Now, let's just look at the batteries first then. Zombie. The new versions that they've brought out are they've got a few different ones, but I'm going to test these two, the 8200, which is the big one, and the 6000. Now, there's a couple of things to notice here. They still rate it at 7.4 volts, which means that when you charge up for competition racing, which is the maximum allowed of 4.2 per cell, which would be 8.4 cut off, you should get the full capacity. Now, when you take another pack, a lot of these have become high voltage, so-called cells now, which can be charged to a higher voltage. But if you only charge the lower voltage, which is 7.4 or 8.4 cutoff, you will not get the capacity they rate. You only get this big capacity if you charge it to the higher voltage. So an 8.4 is more like going to be an 8000 or an 8.2. Notice it's still 120C. Most batteries are peaked out at 120C, 130. Some manufacturers like to boast of higher C ratings, but I mean, I don't know how they arrive at that. So 120C, here's the 6000 version of the IP, the latest one out. Also, you've got, for instance, this one that I've tested and I rate very highly is the LRP version, LCG stock spec. This is the 6400 version. Also an HV, high voltage version, i.e. 7.6 volts. So capacity will be lower when charged only up to the 7.4 volt. So now the zombies, if you look at them, as I said, they got the spec on the side. They've got 6,000 and 8,200. Having a quick look at them, nice black case, zombie embossed. The way that the labels wrap around the side is what is the best way, because if we use tape across the middle, it doesn't rip it off. So most manufacturers have finally realised that and done that. Nice shiny labels. LCG, low centre of gravity they call it, and that means it's thinner, I think about 22 mil. I mean, I'll measure it. Connectors, you've got the 5mm sockets, which is what all the manufacturers have moved to for increased power delivery, so better surface contacts would pass more current, so that's good as well. Doesn't go all the way through. A lot of manufacturers have these go all the way through, so you can fit it in either way around the car for your plus and minus. They don't, and that's the 6,000 version. The 8,000 version, I still call it LCG, even though it's the maximum thickness I think allowed under the rules, about 25mm. So I can't see how it's a low centre of gravity. It's heavy too. I'll do the weights. So that is about the maximum size of a hard case battery that you can get, and that's to get the capacity, 8,200. Just a quick look at the other one, I'll just show you to compare it. The Zombie doesn't come with any connectors or anything. If you buy the IP, you get a lead which has got a Dean's connector on it, and 5mm plugs and everything. That's, I think, for some speed controls and that come with Dean's connectors. I'm still not sure why they still give you that lead. It's a generous thing. They also give you some 5mm plugs and a 2mm plug. Very generous for the price. Now this is the 6001 LCG again, thin, 22mm. Labels around the side. A lot more printing on the bottom, which I believe this one doesn't have. Don't need all that information really, but they put it on. They call it silicon graphene. I think all of them call them silicon graphene now. So that's the 6000 version. As you can see, the plugs, sockets go all the way through now, and they give you a little blanking thing, which is quite nice. They don't fall out. Some other manufacturers have some ones that just fall out, so you can fit it either way around. And the big 8400, which we're going to test to compare, full 25mm thick, again the sockets through, same labelling. So that's in my opinion, they're both top of the range to compare. It's just to see which one is best. The LRP, they do a big 8400 as well. I think personally that the LRP and the IP are the same battery, just in a different case. And it's true with a lot of these batteries. They all come from the same manufacturer, although I believe you can specify the grade ABC, etc. that you get. So, matter of testing, it takes a bit of a time, so I'll truncate all the testing, put all the results down, and we'll look at them. New Zombie Motors 2018-2019 versions. I've got two here, the 17.5 and the 13.5. The reason why I'm going to test these is because that's the critical class, especially the blinky class, where everything makes a difference, and the motors especially will make the difference between a fast lap time and a slow one, because the way they're made, the performance of the kV, the torque, everything, the winding resistance and the rotor strength will make a huge difference in blinky class. Not so much a big difference in other classes, boosted and mod. So we'll look at the 13.5 and 17.5. Now, Zombie, Colin Jackson edition. So this is a special edition for Colin, and I believe they're both the same, except 13.5 and 17.5. This is a 13.5 Colin Jackson high torque 13.5 turn. Comes in this little cardboard box. Inside you've got the motor and a fairly long sensor lead. Zombie. Motor itself all black with some alloy edges, silver edges. Having a quick look at it, it's got the holes in the right place to let the air into the coils for cooling. You can see the coils inside. Having a quick look at it now, it's a couple of holes in the back, single sensor port, 3 screws, 1.5mm they look like. A nice clear legend in for the timing. A lot of motors you can't actually read that at all. Nicely 13.5 turn is actually cut all the way through the can, so there's going to be no mistake in that. Here it says Colin Jackson edition, Zombie. The front, some round holes, and the all-important collector plate here is quite big and it's quite thick too, which I think makes a huge difference to the performance. So the motor has even got 13.5 turn etched on the front of the collector plate there. They look like alloy screws from the front, holding it together, and it looks like 3-piece. The front, I believe, comes off. I think it's just joined there, so the front's going to come off, and the back, I think it comes off right at the very back. So 3-piece. I'm going to test it, obviously, and take it apart and measure a few of the things. There is some writing on the flat of the shaft, which tells you the code for the rotor. I can't actually quite read it, but I'll write that down later. The tags for soldering, they look very substantial. They look brass, and they come straight up. You can lay the wires in for soldering rather than being bent over, but they're still solid. They're not circuit board. There's a bit of like circuit board in front, and I can see they've been riveted on the back. Shimming, perfect shimming there, not too tight, not too loose. So initially looks good from the outside. Now how's it going to compare to some of the class leaders? Well, I've got a couple of motors here which win all the races. For instance, the R1 and the new Surpass V4S, which I tested and been exceptionally good result. The appearance, well, the Surpass is completely different. Everything's different about it, from the design of the cam. It slides right on, bent tags in the holes and everything. But the class leading R1, a bit of a similarity. Holes a bit bigger on the Zombie, but black. There's the front, back. This has got some sort of plated solid tags bent over. Quite awkward to solder sometimes. The gaps are quite small and these can move after a while, which can be annoying. Fairly clear legend there. R1 single port. R1 has gone to 2mm sockets on the M-bell holding screws, which I think is excellent, and I wish the others would all do that. These 1.5, sometimes you can round them out. Anyway, the M-bells obviously look slightly different, but side by side initially they look rather similar, don't they? Well, the R1 is class leader, and if the Zombie goes as well or better than that, it's going to be a great motor. Strength, most of the motors now have gone to pretty strong rotors. I would say that's even stronger than the R1, and we know that the Surpass comes with an excellent strong rotor. So I can test everything with the various testers I've got: Gauss, motor analyzer, resistance, and I take it apart and weigh it, all the rest of the stuff. And I have the charts that I write everything on, like this, measuring the kV versus amps, measuring in terms of resistance to the wires, all the things about the rotor, and any other notes, the weight of the motor, and anything else. I've done loads of motors over the time, but I'll only be looking at the a couple of the latest ones, which I think are very good, and compare them. So it's just a matter of getting down to it and doing the tests, and I'll write it all up and we'll see how it comes out. Tuned the 13.5 turn to 6 amps and just run it up. Excellent kV, 4239. That is a little bit higher than the Surpass, and just going to check the timing now. Timing, average 48, spread 47, 50, 47. Not too bad. That's a reasonable, not perfect, but much better than most. So a good timing for a very good kV. 40, only about 44. So it's not very accurate on the scale on the back. Surpass 13.5, 6 amps, 4310 kV. As a quick comparison, this is the R1 V16, 13.5, just on a test showing you what the existing motor is that wins loads and loads of competitions. It's 4254 at 6 amps. The timing 48, spread 48, 47, 50. Taking the zombie motor apart just to see what it's made of and all the little bits here. The main stator and the case are sort of fixed together, so you can't really take it apart, but you can look at the construction. You can see how it's made. It's got Zombie 2018 written on there. You can see the riveting, the thickness of the plates. You can see the aluminium collector and 13.5 turn written on it. I think they possibly had to write that on there because you can't actually see the laminations hidden behind the case, so you can't actually see that the winding is 13.5, so they've had to put it on there instead. Obviously it says 13.5, which has been cut right through. Now it's amazing that a lot of these motors are so similar. If you look at the Surpass, for instance, you can see that the riveted looks identical, and if you look inside at the windings and construction, you can see even the heat shrink they've used inside on the wires is the same. Colour of the wire, it looks a bit redder in this one than that one. I wouldn't say that was significant. I have done some measurements, I'll show you them in a minute. One thing I pointed out when I did the Surpass was I couldn't work out why it was sort of brass coloured on the outside of the collector, and I did notice that on this one it's the same, because it's that film. I noticed on the Surpass they hadn't taken the film off, which was amber coloured. It's just a protective film, and they obviously cut it from a bar of aluminium which has been nice and shiny, so they put a protective film on it like you see on lots of things you buy with protective film. So even that is the same. Even that is the same. Oops. Now the rotor, I haven't got a Surpass one here, but it looks exactly the same again. Even the font is like the same as used on the Surpass, and there's some engraving on here which has a number. It's hard to read, but it says MTZ 725.125. I think I did write it down. The surpass on their rotor, it was 75125. On this one it's 725.125. I'm pretty sure, and it looks identical the way it's stepped and everything, and the black ring and the way it's been epoxied. So these things come from factories who make all the parts, and they either assemble them somewhere else with all the bits they buy in, or it's even made at the same factory. So that and the stator is probably made at the same place. The end bell, I like this. This is nice. This little part here presses on the bearing to hold it in place, which is better than the surpass one. Has like a nub that presses on the centre of the bearing, which I didn't think was great because it presses on the end of the shaft from the rotor and stops you shimming it correctly. This one, the rotor shaft can pass through. It's got a space in the back, so it doesn't press on that. So that's good. Now the centre board is totally different from the surpass one, so that obviously comes from a different place. It's much smaller, tiny little thing, and it's green. The surpass one, which I don't have here, is much bigger, and this one, this green sort of centre board, I've seen before in lots of other motors. There's obviously some manufacturer makes them for lots of people. That's nice. The bits and pieces from the end bell, alloy piece here. There's a little insulator. It's quite thick, this insulator that goes in there. Some other manufacturers use a much lighter paper. It's only to stop you if you're terrible at soldering, I think, your solder gets down there, and if it gets through the anodizing it could short out. It's just a safety thing. 3 aluminium screws, alloy screws, same as surpass and other manufacturers now. They all come included. You don't have to pay extra for that. The front is a little one piece, fairly lightweight, standard size bearing, not oversized bearing. Some manufacturers use oversized bearings, and the hobby wing used a smaller bearing in the back of theirs, which only was a 3mm hole. They'd stepped down the back of the 1/8 shaft to 3mm. I don't know whether that's to save weight, because they could have a slightly smaller bearing. The hobby wing did come out the lightest out of any motor we've ever measured by quite a margin. I've measured the resistance of the coil, which is so important, very, very important, and I won't show you me doing the test again. 0.021, 0.021, 0.021, same as surpass was 2121, and I think one was 22. You must make sure you get perfect connection, so I would say that was the same. That's industry standard, top of the range competition, whatever you want to call it, the best wiring you can get now. It passed earlier motors from a year ago. This is now the new standard 0.021 on my measuring equipment. I measured the rotor Gauss. It was 1500, near enough, quite well matched, 1511, 1490. On the surpass we had a stronger rotor on that one, 1520, 1544. And another one I measured was 1456, 1428. So they do vary, whether or not Zombie specify that their Gauss must be checked and all in that range. But 1500 is spot on for the sort of performance we're looking for. Did measure the weight of the rotor, 26.2 grams. And I think that's the same as the red one. I've got to measure it because it's 2mm shorter on the shaft, which would have shaved off a bit off the 26.7 on the slightly longer shaft on the gold one I tested. That was, anyway, the rotor's near enough the same weight. I did measure the weight of the motor, but I've got to put it back together again to check. I think it's about 151. I'll show you that later. Now the KV has spun it up, and I think I showed you this already. That's 4239. I did test another Surpass one, motor number 2, and it was 4310. So obviously you're going to get some variation between the motors, especially with slightly different rotor strengths as well. I didn't measure the rotor strength for that one, but it just shows you they're very similar. And that's because the construction, the stators, the rotors are the same, and that's determining how they perform now. Slightly lower than this one, 50 degrees to 48, but it's close enough to show how similar they are. So that is the Zombie motor. It's class leading like the others, top of the range performance, going to give you massive performance, top speed on all tracks, small and large, excellent acceleration, small and large. Again, it's an all-round winning motor. So that one, like the R1 before it, and now the Surpass, are all going to be about equal on the track, depending on up to you then how you gear it and drive it. No other parts really to show you, just 3 little screws on the back, shimming, all important shimming. And if you put it back together again with this one, you can shim this. You can shim it right up to the center board if you want. On the Surpass you couldn't do that because the shaft hit the end bell and it would only go in so far. Zombie 17.5 turn, setting it up to measure the KV at 6.0 amps. You see it's a 3549. Timing 52 average, 52, 52, 53. Very good sensor board. M-bell timing. That is 46 or something indicated, so it's a very long way off of what the analyzer measures. Measuring the stator resistance of the coils on the 17.5. First of all, check the meter. So 0.038. And the last one, 0.038 on the tags. Hold on with my 0.038, 0.038. Not as good as the Surpass. I measured 0.036 on the red one, 0.038 on the gold one. So, and previous motors were 0.038. So maybe that's showing up a little bit in the KV as well. The rotor out of the Zombie 17.5, you can see it's got Zombie etched, Team Zombie etched on there, and on the end here it says same as on the 13.5, I can read it, M-TZ-725125 minus 1490 plus 1497, so very well matched. Construction of the 17.5 is the same as the 13.5, so we don't need to take it all apart. It's got 17.5 in grey, well, cut all the way through the case there, and 17.5 turn etched on the collector. The rest of it's the same as the other motor. The 17.5 turn stator length 19.46. the 13.5 turns data 944. Weight of the 13.5 153.3 grams. Weight of the zombie 17.5 149.9. Shaft length that sticks out to the fixing face, it's 15 millimeters, and you can see it's not as short as the surpass one, which is only 13.8. You can see the gap. But it's better than some which are 16 millimeters. Testing the Zombie 8200 on this discharger. I've got it all just come straight off charge. As you can see, it's 8.388. Slight variation in the two cells, but 8.388. So I'm going to start the high current discharge, and I will record the results on the watt meter from the milliamps on there, and then we get the initial drop as soon as I plug it in. Drops to 8.291, and then I'll do it at 200 milliamps draw. We'll see what the voltage drops to. Just coming up to 200 now. 8.113. I do it at 500 milliamps draw, and I'll keep on going to all the way up to 3,500. Just coming up at regular steps, and then I'll discharge it to 6.0 volts. Just coming up to 500. 8.049. I do it at 750, 1000, 1500, 225, and then I'll measure the full capacity when it gets to 6.0 volts discharge. So I'll do it at 750 milliamps, and I can compare it to all the results. Let's just do 750, 7.993. Do it at 1000, and I can compare it to I've done the IP84 and 6000 already. They're all been charged the same and cycled the same. It's just coming up to 1000 milliamps. 7.952. Measuring obviously the voltage directly on the terminals now with this meter, and this week just I can read off the capacity as it discharges through this high current discharge box. So I'll take another reading at 15, 2000, etc. So once I've got all the results, I'll be able to compare the batteries. I've got the Zombie 6000 I'm going to do as well, and I've measured the IR on the charger, on the iCharger when I charge it up. It gives some indication of the quality of the battery, and we'll see what the two cells are at the end and the temperature. Just coming up to 1500 now. There, 7.817. And I'll measure it at 2000, etc. And then all the results are I've got on this chart down here, recording it all here, and I'll show you the results at the end. There's 7.728. Just coming up to the end of discharge on the Zombie 8200. I'm going to take it off at 6.0 and we'll see what the capacity is. Right, it's going pretty low. There you go. Near enough. Capacity 7819, 7,819. Oh, 78. Just pop. 7820 says now. 7820. Temperature. Let's just do the temperature. (45 degrees). 45 degrees C. I don't know if you can see that. Individual cells, it's just recovered quickly, hasn't it? Just recovered quickly. 3.28, 3.37. You always get a bit of imbalance if you fully discharge it down to next to nothing. 6.0 volts. I wouldn't recommend. Most people do it down to 6.0 because that's as low as you want to go. So that was the 8.2. Charging the Zombie 8200 just to check its performance. The cells are perfectly matched, just come off charge, 4.197 each. Internal resistance 1.3, 1.3. So discharging the Zombie 8200 just to see how well the cells are matched, and they are perfectly matched. 3574, and the IR was 1.3 per cell. Testing the Zombie 6000, it's just come off from being fully charged, and I'll start the discharge and see how it gets on. Drops initially to 8.296, and then at 200 milliamps we get a reading, which is a lap or two in your race. 8.108. I'm going to do 500 milliamps, which is 4 or 5 laps. The 8.013, and then 750, and I'll keep going like I've done with the others, and record it all the way to the end, see what capacity it is. Let's do 750. It comes down really fast, as you can see, with discharging at this high current. 7.952. Keep doing all the tests, and I'm writing them down on this chart here, and then we can compare all the results. Coming to the end of the discharge on the Zombie 6000, I'll take it off when it gets to 6.00. I'm going to measure the capacity. It normally drops very quickly as soon as it gets to the end, which is right there. So the capacity 5862, which is pretty close to the 6000. See that the cells just recovering slightly. They're slightly out at the end, but that always happens when you discharge fully. One cell will always go slightly out. And let's just do the temperature. Not too bad. Probably can't read that. It's just 42.3 degrees C. That is the Zombie 6000. Now all I have to do is show you the charts in a second of all the 4 batteries I've done. That is on this process, and see what the conclusions are. Conclusions of the tests on the new Zombie Lipos and the Zombie Motors 13.5, 17.5, which I've checked out for use in Blinky, where the performance of the battery voltage being kept up during the race is most important, and the performance of the motor is most important. So we look at the motors first. The new Zombie motor compared against this year, anyway, 2018 the R1 motor, which has won loads of races indoors and outdoors. And then we'll also look at the new Surpass motor, which has come up very well, and how they perform next to each other. Well, the R1, I've already said, is very similar in appearance to the Zombie, possibly made at the same place, just different cosmetics, but the Zombie's a bit more up to date. I've already gone over the construction and everything, and how some parts are very similar to others. I've talked about things like shaft lengths and the tags and the front collectors. All those things have been making these motors very similar in performance. So let's just look at the results. I've got the 13.5 results here. I've done a couple of retests on the R1 just to show that it's still consistent. So this is the existing R1 that does so well. The 13.5, I haven't bothered to put it on the dyno because these KV ratings and the tests of the rotors are enough to tell you how good this is going to go. The R1 does 4254, it's tuned at 6 amps, and the timing, it's quite a good timing board on this R1, sometimes they're all over the place. And you can see that the Zombie is almost exactly the same, 4239. I tested a couple of Surpasses and they varied from 4310 to 4175, so it's still the same area. Now, measured accurately the resistance to the stators, which is going to tell you how the motor is going to generate any heat, so at the end of the race you need it to be as cool as possible, and the lower the resistance the better. 0.021 is the new standard. It's the lowest we've tested so far. Previously nothing got that low, and in fact the R1 is 0.022, just slightly above it. The weight, R1 on 48.8 grams. That might be because with the new stator, perhaps the wire, perhaps the steel they're using, the weight's gone up slightly. 153.3, 155 for the Surpass. Magnetic strength, around about the 1500 Gauss range. That seems to be the Gauss that manufacturers are going for to give you the excellent acceleration. And with the high KVs you get fantastic acceleration and fantastic top speed as well. So the best of all worlds. I checked a few other things. The length of the shaft sticking out where you put the pinion on, you don't want it too long. Some of them were 16mm or even longer before. The Surpass only 13.8 is nice and short. These are still a 15mm. I checked the rotors. The rotor numbers, as I observed, I think the rotors are exactly the same, made at the same place, just got the different name on it. Stator width down to the minimum now. There's no point having a big stator, it's just heavy. I don't think it gives you any advantage. So they're all about 1945, 1946 millimeters on the lambs. Anything else? I did measure the weight. I've already spoken about that. Yeah, the rotors seem to be identical. Now that's the 13.5 turn. Now looking at the 17.5 turn results, these are much better than some of the previous motors that we've seen. Looking at the 17.5 turn results of the Zombie and versus the Surpass, and I haven't retested the R1, but I've got some results from previous. Looking at the weights, if you like, because now with the weights of the cars coming down all the time, you don't want a heavy motor. So 152.2 Surpass, 149.9 for the Zombie, which is good, and the R1 previously 151.2, so all about the same. Now the R1, which has done so well previously, 3426 kV. Now we've got a better kV, 3549, and even higher on the Surpass, 3688 I measured on that one. Winding resistances used to be 0.038, still 0.038 on the Zombie, but the Surpass, for some reason I'm getting a new class lead in 0.036, and that's possibly why the kV is up now. So somehow or other Surpass is ahead of the game here. Again, measuring the rotor Gauss, just over 1500. Previously on the R1, 1475, dropped to 1491, still about the same area. This Surpass was only quite low, 1469, but I think these rotors, they just vary at manufacture from low to high. On the other Surpass one I measured, it was 1544. So they're all about the same. If you get a different rotor strength, you have a slight difference in performance, but it's not going to be huge on the track. Just looking at finally at these 17.5. I've shown the kV, timing, internal resistance, stack length is around the same, 19.4 something. Gauss, same number again as in the 13.5, exactly the same rotor number. I didn't write it down there, but it is the same number as the other one. Shaft length, weight. So those are the motors. You've got all three of these are still going to perform brilliantly on the track. 17.5 Surpass might have a slight edge, especially as it's got slightly less resistance on the winding. That's on the 17.5. The 13.5, nothing between them. The Zombies, the R1 and the Surpass, all capable of winning races indoors and outdoors. Moving on to the lipos. Now, lipo testing, a lot of work to do the lipo testing to make sure I got accurate results and you can compare. I've taken a few other batteries to compare to, IP846. I've looked at the LRP64 and the Sumperdow 6000. I haven't actually tested yet, but I'm just going to show you the differences. The one problem with comparing lipos is the weight. Some of them are much heavier than others. On here we've got 333 grams, 327 grams, 270 grams, 290 grams, 273 grams, 294 grams. So massive, from 270 to 333. And it's going to depend on what weight you need for your car. With the new weight limit on touring cars competition coming down to 1320 grams, it's going to be very difficult to run a heavy battery. Indoors, it's probably an advantage to run at that weight limit. Lower centre of gravity, less chances of grip rolling, etc. And plenty of acceleration with the lower weight cars. Outdoors, 1320 grams versus 1350 grams. It may, if the grip isn't high, there may not be any advantage in running 3020 in this class, 17.5, 13.5, which we're looking at the voltage of the batteries for that class, modified as I said before and boosted. Battery voltage is not so important, so you might select on weight. I did check the IR on the iCharger. It does vary depending on whether you cycled it up or down, and if you charge it fully up or discharge it fully. I did it a couple of times. So these are only indications. All of them got very low internal resistance, though I did notice that the IPs appear to have slightly higher IRs than the others. Did a couple of discharge ones, but it just takes too long. The discharge resistance on the iCharger, if you've done it properly, tends to come out the same anyway. Anyway, looking at the results, as I said, how are you going to select which one to use? Because here are the voltages as it discharges at about 30 amps, which is about the average during a race. I've measured up to 3,500. With a 17.5 turning blinker, you probably draw 2,000, a 13.5 maybe 3,000. So I stopped there, and then I measured the full size. So let's just look at divide it up slightly. When you start off, you want the max first few laps, how fast you're going to go. It looks at 750 milliamps drawn. The higher the voltage, the better. You can see that the bigger the capacity, 8,400, the higher the voltage stays up, which is only sensible if you've got these batteries which are all incredible low internal resistance. So you've got the Zombie, that's the one we're looking at 1,000 milliamps, say halfway through a race for 70.5. Zombie 7.952 is just ahead of the Intellect 8.4, and it's ahead of the others as you would expect due to the large capacity. The capacity measured when stopping at 6 volts, which is as much as you can get out of these things. I didn't expect the Intellect 8.4 to get to 8.4 because it's a 7.6 volts and I've only charged it at a 7.4. It only made 7,600 milliamps. The Zombie 8,200, which is a 7.4 battery, I only got 7,820 out of it, which is close, nearly. Those are the two big ones. Which one to use? Well, the Zombie edges it. It's got fractionally higher voltage all the way through, and it's slightly lighter in weight. But I believe it's quite expensive. I think it's about £90 retail compared to only 73. So if money comes into the equation, the Intellect is much cheaper. Also comes with a little lead and some connectors thrown in. Let's look at the others. Well, you've got two here. You've got 290 grams, 294 grams for the Zombie 6000, and the LRP and the Intellect 6000s are only 270 odd grams, so another 20 grams lighter. So you have to decide how light you want your car to be, or whether you can take the extra weight. So assuming that the weight's not important on the 6000 range, at 1,000 milliamps, 783, 7869, 7844, hardly anything in it. Zombie's just slightly ahead. End of the race up to the 75, 7593, 7634, 7593. Zombie is ahead, but I would expect it to at 290 grams, 20 grams heavier. It's got more, obviously, chemicals in there, and it's just going to edge the voltage. The capacity, the Zombie almost made 6,000, which it should have. The IP 6000 made 5.5, which I expected, it being a high voltage, not fully charged high voltage. The LRP 6.4, also a high voltage, made 5.7. The Sumperdow, I have tested the Sumperdow previously, and it's very similar to the, came out very similar to the IP, but it's just a comparison. It's only got 4mm sockets on it. It is reversible, and it's even got a reversible 2mm plug, which is about the only one I know, which is very useful if you've got it upside down. Anyway, we're looking at the Zombie, and it is better than these other 6000 ones, but it's heavier. Conclusions? Well, all these batteries are fantastic, and depending on the weight, if weight was no object, you'd use the very big ones. After that, if you want a 90-gram one, yeah, the Zombie's the best one. If you want a 270-gram one, there's nothing between the LRP and the Intellect, in my opinion. Nothing really between them. So you'll have to draw your own conclusion. All these batteries are excellent, top of the range. I haven't found a battery that's better than them yet. So it's a matter of weight versus performance, and you'll have to choose it accordingly. Also, don't forget the price. As I've already said, some of these batteries are cheaper than the others. The Intellects are much cheaper than others. 70 quid for the 6000. The Zombies, as far as I know, are £90. The LRP's £82. Some has had a reduction. It was 80. You can get them for 70 at the moment. Maybe they're going to bring out a new one. Same with the motors. Motors are £90 for the R1 Zombies. Only £65 for the Surpass. So if you're budgeting, you can take into account the price as well.